All right. So we left off on number 8. Do you guys remember how we came up with this z-score of 1.04? Does anybody remember at all? And why were we going for 0.85 when up here it says 15%? Yes. So we'll only see, you can put it on my desk since both of those trays are full. We wanted the upper 15%, but though table A gives us the less than, so we did 1 minus 0.15 to get 0.85. And then we looked up in the center of table A. Let's see, yep, I got a table A right here. 0.8508, that was as close as we could get to 85%. And then we read the values. Go left side first, that gives you your ones place, your decimal, and your tenths place, and then up at the top gives you your hundredths place. Z-scores are only going to go out to the hundredths place. All right, so coming back here, now we need to use this because we're trying to find the speeds. Do you guys remember the formula for z-score? Z equals what? Close. It's minus. Value minus the mean over the standard deviation. Well, we have a z-score. So in the place of z, I'm going to put 1.04. Do we have a value for the mean here? 80. So I'm going to call this x and then minus 80 over our standard deviation. Do we have that? 7.7. All right. Solve that for x now. Yep. Good question. What are you guys getting for x? 88.008. If you're driving in a car or an officer pulls you over when you're driving in a car, is he ever going to say you're going 88.008 miles per hour? No. So let's go ahead and round this to what makes sense in the situation. So we'd say 88 miles per hour. All right. So before we go over to page 13, there's a couple things that now that we've practiced, like using our z-scores to find percentages, I want to go back and show you the notation that you would be expected to use on a test, especially the AP test, but on a chapter test in here. What's the notation so that I know that you are calculating the probability or the proportion? So I'm going to go back up to number 6. So do you remember how I said table A here? So here's what our notation needs to look like. We are going to find the probability that our value, we're going to call that x, is greater than what? We wanted x was greater than 85. probability that x is greater than 85. And that's where we calculated our z-score. We looked it up on table A. We did 1 minus. So if I wanted to be really, really clear, I would say that is the probability of 1 minus the probability that x is less than 85. Equals, and then we'd have 0.2578. Or you could write it as a percent. It does not matter whether you write it as a decimal or whether you write it as a percentage. But this is the notation. If you had this and then you jumped right to here, that would be okay. But this shows me what you are calculating. So this, along with your answer and the picture, shows me what you're calculating. That gives me all the information that I need. I know what you're using as the mean because it's marked here and it's inside the parentheses. I know what the standard deviation is. That's here, and it's right here in the picture. You've shown me with the shading what you're calculating. So here's our x value, 85, and we're shading to the right. That's what this says right here. The proportion, the probability, the percent that x is greater than 85. That's what this picture is showing, and so here you're stating explicitly, and here you have your answer. I want to show you guys how you can use the calculator to get to this, because you can use your graphing calculators to get to this without having to use table A. You can use either one on the AP exam. They don't care. They'll give you table A on the exam. You have to have the graphing calculators on the exam. So it's just kind of personal preference, but I'm going to show you guys how to do this on the calculators. So grab your graphing calculators for me. Did that just go away? Nope, there it is. Okay. So graphing calculators. We're going to start off with the second key. Right here. And then do you guys see this button that says VARS, V-A-R-S? We're going to click that. Option number 2 says normal CDF. Before I push that, can everybody get to this screen right here?
So
Second VARS. I want to make sure everybody's on the same page before I move forward because I don't want to lose people along the way. So second VARS, we're going with option number 2, normal CDF. And we'll talk in a later chapter about the difference between PDF and CDF. But you're going to use CDF for everything that we're doing with normal. So option number 2. Some of your calculators will show you this. Some of them are just going to say normal CDF with parentheses. The first thing that we put in is our lower bound. So on that problem that we were just looking at, what is the lower bound on the picture? Where did we start shading from on the left? 85. So that's going to be what I type in first as my lower bound. If it has parentheses, just type in 85. If yours has parentheses, you need to then type in a comma for the next piece. Comma is right here next to the parentheses buttons. Then we're going to put in our upper bound. Well, where did we stop shading at? Did we have a place to the right that we stopped shading? Kind of trailed off forever over here, right? So the calculator can't handle infinity. So we have to put a number in there that's so large that we're sure we got all the way to include all the data. If my mean is 80, my standard deviation is 7.7, give me a number that is so astronomically large that it would have to contain everything. 5,000, sounds good. 9,000. Pick a really big number. Let's go with 5,000. Those of you that just had the parentheses, it doesn't show this screen. You need another comma now. Then we need our mean. What's our mean? 80. Then you put in another comma. And we need our standard deviation. What was our standard deviation? 7.7. This is what it should look like before you hit enter. Is that what yours looks like on the screen? All right. So here's the lower bound. Oh, that is really horrible. Lower bound, upper bound, mean, and standard deviation. When you write this down on the paper, because that's what you're typing into your calculator, you don't have to put all the calculations down, but you do have to show them what you're putting in the calculator. You've got a label underneath each of these because they want to see that you know what those different things are, what they mean. So you could label them lower bound, upper bound, mu, and sigma. You had a question for me?
I'm going to make it look like what you had.
That looks perfect. What I had on my screen when it had all those prompts, that has to do with the generation of the calculator. My emulator is an 84, and so the 83s don't have those prompts, but you're still putting in the same information in the same order. All right, hit enter. What do we get? 0.25805. Yep. Did we have something very close to that? Yes. Calculator is doing it more precisely. Remember, table A, somebody had to calculate all of those out. And so those are like approximations, those are rounding. The calculator is doing it more precisely. You don't have your mean in there. 85, 5,000, mean of 80, then the standard deviation. Yep, well, we're going to practice again with another one. Give me just a moment. Okay, so here's what you need to have. So here's what I would do if I was answering this question on the AP exam. Here's what my work would look like. I'd make sure to have my picture. Then I would have the probability that x is greater than 85. Then after that, I'm going to type what I'm doing in the calculator. I'm going to write that down. So I'd write normal CDF. Parentheses. 85. That's my lower bound, and I would label it. Upper bound. We picked an astronomically large number. You have to show what number you're using as your upper bound. Upper bound. Then we had our mean of 80, so I'm going to label that as mu. Then the standard deviation of 7.7. And we got 0.2580, right? This right here, the picture and this right here is what I would have for my work on this problem if I was doing this on Chapter 2 test, on homework 2, which is due on Wednesday now, by the way, I'm giving an extra day for that, or on the AP exam. This is what I would show. I want to practice writing that and then using the graphing calculator again on number 7. So let's go look at that on number 7. If you do it on the graphing calculator, you don't have to touch table A at all. All right. So help me out. I would need my picture right here. What's my probability statement then going to look like? Yep. 70 is less than x, which is less than 85, equals, now what are we typing into the calculator? Yes. 95, thank you. Thank you for correcting me. I had 85 on the brain from the last problem. All right. What function are we using on the calculator again? Normal CDF, so normal CDF, open up my parentheses. What's our lower bound going to be this time? 70, label that as your lower bound, comma. What comes next? 95, label that as your upper bound. Then we need our mean, 80. Label that as mu. And standard deviation, 7.7. There's our standard deviation. Close my parentheses. I'm going to have to write my answer down here. Let's go practice putting that in the calculator now. How do I get to normal CDF again? Second in vars. Second, vars is right next to the clear key. Normal CDF, option number 2. Lower bound this time was 70, and then you need a comma. Upper bound is 95, then you need a comma. Put in your mean, and then a comma, and your standard deviation of 7.7. And then close your parentheses, and hit enter. What'd you get? 0.87727. So 0.8773. Was that pretty close to when we used table A? We're off 0.03% difference. That's a wash in statistics. Being off by 0.03 between the two answers, it's considered to be the same answer. Close enough. All right. Let's look at number 8 down at the bottom here. Number 8, we were going the other way, right? Does anybody know what we call a function that undoes another function? It's called an inverse function. We're going to use inverse normal if we want to use the graphing calculator. So I would say inverse and then norm. I'm going to show you guys where to find this on the calculator. I'd want the area that I'm looking for. What was the area that we wanted? We wanted the top 15%, which means I need 0.85, 85th percentile. So 0.85. I'm going to label that as my percent. Then you need a comma. And then it's mean and standard deviation again. So 80, mu, comma, 7.7. There's my sigma. I would write it down just like this, and I would label it just like this. If you have the picture together with this information and your final answer, that is considered full amount of work. All right, so on the calculators, we're still going to do second in vars. And now it's option number 3. Inverse normal. Yours then just opens up parentheses, right? Yes? No? Tell me you're looking at your screen. Okay, yours opens up parentheses. So we want 0.85, mean of 80, standard deviation of 7.7. So this is what it should look like, only yours doesn't say left, right? That's because mine is an 84 and you guys have 83s. Don't worry about that piece. Yes. All right, let's go and see what it's yelling about. You have to close your parentheses. It gets real finicky on these calculators if you don't close your parentheses. It's still not working. Inverse norm. Oh. 0.85. What did it give you? 87.98. If we rounded that, because we're talking miles per hour, that would be 88 miles per hour. So I'd say 87.98, which is about 88 miles per hour. So Friday, we're talking big ideas and how to draw the pictures. Today, we've gone over how do we put it into the calculator and how are you expected to show your work if you're using the graphing calculators. Now we can go ahead and turn over to page 13. So a couple things. I want you to add this little bit to that picture. We need to mark mu. We need to mark sigma. It needs to say n for normal. It's because later on, not until second semester, but later on we're going to learn about different types of distributions, not just normal distributions. So we have to label them. And then we need our mean and our standard deviation. You can use table A, or you can use the calculator. So I've got the calculator directions written here. If you want to add those to your page so that you can remember how to do that, please do so. If you're given a value and you want the percentage, you want the probability or the proportion, second vars, normal CDF, lower bound, comma, upper bound, comma, mean, comma, standard deviation. If you're given a percentage and you want the value, you want the X, second in vars, inverse norm, percent as a decimal, and remember that has to be the percentage to the left. So if we're trying to find something and greater, we have to do 1 minus so that we get the area to the left. And then mean and standard deviation, all separated by commas with our parentheses. I want you guys to practice on part A and part B down here with this. So drawing your picture, you can find your z-score and use table A, or you can put it into the calculator. If you choose to use the calculator, you have to show what you're typing in. So it has to say normal CDF in parentheses. You need your probability statement, P parentheses. What are you finding? So I'm going to give you guys about 5 minutes to do part A and part B down below, and then we'll compare yours with mine. As soon as my thing cooperates. All right. So part A, your picture should look like this. These are the pieces of information that you need on your picture. You need to have your mean right in the center. You need to show your standard deviation. You need to have n with parentheses, mean and standard deviation. Make sure those are labeled. I need to see the value, that 300, and then because it's at least, I'm going 300 and to the right. So you can do this one of 2 different ways. In purple is how I type, is what I would show. That's the work that I would show if I'm using my graphing calculator to calculate it. And the work in black is if I was using table A. Yes, Amy?
Yeah, so for the like greater than and less than sign, you can't use a line under it.
The or equal to?
Yeah.
So strictly technically speaking, no. Would it be counted wrong? Probably not. But when we're talking statistics, we almost never, ever, ever use the or equal to. And we'll talk later about why that is. I think it'll make more sense when we get there. But we'd be talking like greater than 300. Yes?
Since I use 5,000, that technically because like my
Nope.
answer rounded up is still 86.
Nope, that's fine. I just picked an upper bound of 9,999. If you had an upper bound of 5,000, that would be fine on this one. It's going to change your answer a tiny little bit, but it's going to round to be pretty much the same as mine. An upper bound that you would not want to choose on this, I think something like 500 would be too small. Look at where your mean is. Look at what your standard deviation is. You want to pick a large number in comparison to, what would 3 standard deviations out be? Pick something larger than that. Quite a bit larger. For the second one, this is where you would have to use the inverse normal. If you worked backwards, you'd have to look up your z-score in table A. And then you'd have to work backwards from there. Your picture for an inverse normal situation, you have to show me which part is shaded. This is the value you're looking for. We don't know what that is, but then you do have to indicate how much of it is supposed to be shaded. In this case, we're saying that 10% of it is shaded, or 0.10. So I did all of that to calculate how much waste was produced if it was 10th percentile. Ballpark 223 pounds. And then they get $5 per pound. So I just took the amount of waste and multiplied it by $5. What I want to spend our last 10 minutes working on, and I'll answer questions in here too, that single sheet of paper that you picked up on your way in. Not the stapled one, but the one that says more practice with normal distribution calculations. That single piece of paper. That's not a homework assignment, that's in-class practice with this. I want you to partner up with somebody and work on as many of those problems as you can get to. You're going to turn it in at the end of the class period so that I can see kind of where you guys are as we go into getting ready to review, so that I know what we still need to hit on. This is such a hugely important idea in AP statistics. Being able to draw the picture, being able to label it appropriately, knowing how to put it in the calculator, knowing how to write down what you're putting into the calculator, and then writing down your output. So find a partner, partner up. It can be groups of up to 3, no more than 3 in a group, preferably groups of 2. Work through as many of those 4 problems as you can get to in the last 10 minutes here.